Hey everyone, I hope you're doing well today. In this video, let's talk about finding the area of parallelograms and triangles. Simply put, area for parallelograms is equal to base times height. Using variables, we typically write this as capital A is equal to lowercase b times lowercase h. To simplify it even further, we write capital A is equal to bh. To show you what this looks like, let's consider this rectangle. The base would be the length across the bottom, and the height would be the length going up and down. Filling this rectangle up with a bunch of little unit squares, we can see that the length of the base is equal to 5 units and the height is equal to 3 units. It's really important to understand that area is just how many of these 1 by 1 unit squares that are inside of a shape. The area of one of these individual little squares is equal to 1 square unit, or 1 unit squared. While we could count up that there are 15 of these little squares inside of this rectangle, we can also use our formula. Writing our formula, A is equal to BH, and substituting in our values, A is equal to 5 units times 3 units, 5 times 3 is 15, and U times U is units squared. Because multiplication is just a shortcut for addition, we can multiply 5 times 3 to get how many squares are inside of this rectangle. What if we don't have a rectangle and we have a parallelogram that looks like this? The base is going to be across the bottom again, but our height is going to be the distance up and down. Be careful not to use the length of the diagonals or the slanted sides as the height. To make sure you have the correct height measurement, make sure it makes a 90-degree angle with the base, or is perpendicular to it. The tricky thing about finding the area of parallelograms is the fact that they don't have just normal squares inside of them. They have bits and pieces of squares as well that we're going to have to cut and paste together. Just so you can visually see what I'm talking about, let's use the same dimensions as the rectangle that we were just using. So remember that the base was equal to 5 units long and the height was equal to 3 units. It's important to understand that a parallelogram is really just a rearranged version of a rectangle. If we look at this upside down triangle that's on the right side of this parallelogram, we can actually move it to the left side of this parallelogram and complete the diagonal side over there. By cutting this part off of the right side of the parallelogram and rearranging it to the left side, you can see that we actually just form a rectangle. Because area is just a representation of how much space there is, it doesn't matter if we have it on the right side or on the left side. Because of this, we can then say that to find the area of any rhombus, rectangle, parallelogram, or square, we can just multiply the base times the height. While compared to the rectangle we saw earlier, this parallelogram is slanted, it takes up the same amount of space or covers the same amount of squares as the rectangle did. Now let's look at how to find the area of a triangle. For triangles, area is equal to 1/2 times the base times the height. Simplifying this a bit more into an algebraic equation, we can write capital A is equal to 1/2 times lowercase b times lowercase h. And simplified even more, we can say that capital A is equal to 1/2 bh. Hopefully you notice that this formula actually looks very similar to finding the area of a parallelogram. The only difference here is that we have a 1/2 in the formula as well. It turns out that when you're finding the area of a triangle, as long as you have the base and the height, you can also find the area. Let's consider this triangle. The length of the base is going to be going left and right along the bottom, and the height is going to be the length going up and down. Remember, when we're looking for area, we're seeing how many of these full squares we have that are inside of this triangle. Using the same dimensions as earlier, let's say that the base is equal to 5 units and the height is equal to 3 units. If we go ahead and draw the length of the base that's on the bottom on the top and the length of the height that's on the left over to the right, we can see that we have a full rectangle. If we were to draw the rest of the squares, they would look something like this. Compared to the full rectangle, let's see how much space the triangle takes up. Hopefully you can see that the triangle that we have takes up half the amount of space as the rectangle given the same base and height. Or thinking about it in a different way, it takes up half the amount of space or has half the area. To find out how many of the squares are inside of this triangle, using our formula we can say we have 1/2 times base times height, or 1/2 times 5 units times 3 units, and 5 times 3 is going to be 15 units squared, and half of 15 is equal to 7.5 units squared. If there were 15 squares that made up the original rectangle, we could fill 7.5 squares in one of these triangles. To summarize, it's really important to really understand what area actually is. Basically, area is just telling us how many of these 1 unit by 1 unit squares are in each of the shapes that we have. One of these little squares has the area of 1 square unit, and the area of any shape or any 2D shape is the number of these 1 by 1 unit squares inside of it. These are the two important formulas that you need to know to find the area of parallelograms as well as triangles. Example 1. Let's find the area of this parallelogram. Looking at this parallelogram, the first thing we want to do is find out what information that we're given before we start the problem. First off, this 50 down here, that's just going to represent the base, so we can say that B is equal to 50 feet. And then this 100 feet over here to the left, that's just the height of the shape, or the height of the parallelogram, and that's going to be 100 feet. What we're going to be doing is we're going to search for the area, or capital A. To find the area of this parallelogram, we're going to use the formula capital A, or area, is equal to the length of the base, or lowercase b, multiplied by the height, or lowercase h. Now, we don't know the area, so we can just leave that as capital A, and say that capital A is equal to the base, which is going to be 50 feet. We'll substitute that in, so we'll have 50 feet multiplied by the height, and we're going to substitute in that value of 100 feet. Okay, so we're going to have to multiply these together, and if we multiply 50 by 100, well, 5 times 1 is going to be 5, and we have 3 zeros, so it's going to be 5,000. Okay, and then when we multiply feet by feet, feet times feet, that's just going to be feet squared. Therefore, we can say that the area of this parallelogram is equal to 5,000 square feet. And basically, all that means is that we can fit 5,000 of these 1 foot by 1 foot squares inside of this parallelogram. That's how much space is inside of it, or the area. Let's try another one here. Looking at this 12 meters along the bottom, we know that the base, or little b, is equal to 12 meters. Now, as for this 7 meters, this 7 is going to represent the height, so we can say that the parallelogram here is going to be 7 meters tall. Based on this information, we're going to look for the area of this parallelogram. Now, the formula we're going to use is going to be A is equal to base times height, or little b times little h, and substituting some values in here, we can say that the area is equal to, well, we have this 12 meters for the base, so we're going to write 12m, or 12 meters, and we're going to multiply that by the height, which is 7 meters, so we'll multiply by 7 meters. Okay, now, next thing we're going to do is just multiply the numbers together, so if we multiply 12 times 7, 12 times 7, that's going to be 84. I'm just going to go ahead and write that down. It's 84. And then meters times meters, that's going to be square meters. The area of this parallelogram would be 84 square meters. Basically, we can fit 84 of these 1 by 1 meters inside of this parallelogram. For this third example, notice how there are these little tiny tick marks on each of the 4 sides of the parallelogram. This just means that each of the 4 side lengths are congruent or equal to each other. Whenever that happens, this doesn't really change how we're going to solve or find the area, but just be aware that this just means that this shape or this parallelogram is more specifically called a rhombus. Looking at the information we're given here, this 9 centimeters across the bottom means the base is going to be equal to 9 centimeters. And looking at this 8.6 centimeters, that's going to be the height. So we can say the height is equal to 8.6 centimeters. Now, since we're given a base and a height, we can solve for the area. Let's start by writing our formula. We have area is equal to base times height, and let's make some substitutions in. So we know that the base here, what's the base equal to? That's 9 centimeters, so we can write 9 centimeters, and we're going to multiply that by the height. And the height we were given is equal to 8.6 centimeters. Let's just go ahead and multiply 8.6 times 9 on the side to find out what the area would be. So 9 times 6 is going to be 54, we'll carry the 5, and 9 times 8 is 72, plus the 5 is going to be 77, and we have 1 decimal place value, so we're going to have 1 in our solution. So the area here, which makes the most sense, is going to be 77.4, and then centimeters times centimeters is just centimeters squared. This is how many square centimeters there would be inside of this rhombus. Given that the base of this rhombus was 9 centimeters and the height of the rhombus was 8.6 centimeters, if we were to fill up this rhombus with a bunch of these 1 by 1 square centimeters, we could fit 77.4 of them inside of it. For this fourth example, let's try finding the area of this parallelogram. So first of all, we know that the base here is going to be 18. So we're going to say the base is equal to 18 inches across the bottom. And then this 2.5 inches, that's just our height. So we can say h is equal to 2.5 inches. Given that information, let's find the area of this parallelogram. Okay, so going ahead and writing our formula, we know that capital A, or the area, is equal to the base times height, or little b times little h, and we can make some substitutions in. So substituting in, we can say capital A, or the area, is equal to 18 inches, that's the base, so we'll write 18 inches, and we're going to multiply that by the height, which is going to be 2.5 inches. So that's going to be 2.5 inches. Okay, so setting this up, we can just write our area is equal to, and let's get to work and just multiplying these values out. So if we're going to multiply 18 by 2.5, we're just going to want to remember how to multiply fractions, and when we do so, we really want to have improper fractions. So 18 is going to be 18 over 1, and 2.5, it's the same thing as 5 halves. So we'll write 5 over 2. Multiplying fractions, you could just multiply and then simplify, or we could cross cancel along the way here. So this 2 and 18 can cross cancel. They have a common factor of 2. That's their GCF. So we can simplify that down to 9 and 1. And multiplying these together now, on top 9 times 5 is going to be 45. And on bottom, 1 times 1 is equal to 1. So we know this is just equal to 45. So the area of this parallelogram is going to be 45. And then inches times inches is going to be inches squared, or square inches. The area of this parallelogram is equal to 45 square inches. What that means is that we could fit in 45 of these 1 by 1 square inches inside of this parallelogram. For example 5, let's try a slightly different type of problem. In this problem, we have that b is the base and we don't know what that is. We're going to leave that alone. We're given that the height here is 7, so we can say h is equal to 7 centimeters. And in this problem, we actually don't have the base, but we are given the area. So we can say that capital A, the area is equal to 105 centimeters squared. We're still working with parallelograms here, so our formula is going to stay the same, saying A is equal to BH. And making some substitutions here in, we know A is going to be 105 centimeters squared. We're given that information in this problem. And it's going to be equal to the base, which we still don't know. It's going to be our unknown, and that's multiplied by the height. In this case, we know that's going to be 7 centimeters. Now, whenever we multiply a variable by a number, we typically write the number as a coefficient first. So on the right side, I'm just going to rearrange this and write 105 centimeters squared is equal to 7 centimeters multiplied by the base, where b is the base, or the unknown variable, and 7 centimeters is our coefficient. Now, thinking back to our one-step equations, how are we going to isolate or solve for b? Well, the inverse operation here is, instead of multiplying by 7, we're going to divide both sides by 7 centimeters. If we do so, then on the right side, we're going to notice that this 7 centimeters and 7 centimeters are going to cancel out, since 7 over 7 is just 1, and centimeters over centimeters just cancels out. So on the right side, we know we're just going to be left with the variable b, or the unknown that we're solving for. However, on the left side, we're actually going to have to do a little bit of work, right? So we have 105 divided by 7. And while we could use a calculator, or you might be able to do this in your head, I'm just going to write it out to be very thorough here. 7 fits into 10 one time. That's a 7 with a leftover, or the remainder is a 3, and we have a 5 as well. 7 into 35 is 5 times. 5 times 7 is 35, and it goes in perfectly. So 105 divided by 7 is going to be 15. I'm going to go ahead and write that on the left side here. That's going to be 15. And then when we check out our units of the centimeters squared, well, if we have centimeters times centimeters on top and we have centimeters on bottom, that just cancels out and we're left with plain old centimeters. And hopefully that makes sense for our units, because if we have the base is equal to 15 centimeters, that should be in one dimension and not two. Given the area and the height of this parallelogram, we were able to solve a one-step equation to solve for the base of this parallelogram. In example 6, let's try finding the area of a triangle. It looks like that we're given the length of the base, so down here, this 10 inches, we can say that b is equal to 10 inches. And then this 9 here looks like it's the height, so we can say the height is equal to 9 inches. Let's go ahead and see if we can find out what the area is. While we have this formula for finding the area of triangles right over here, keep in mind that we could also use an alternate version of it, which is just saying that area is equal to base times height, and then dividing that value by 2. To find the area of a triangle, we can say that it is 1/2 multiplied by the base multiplied by the height, or we can say it's base times height, then divide that product by 2. Whichever version of this formula you choose to use is up to you. I'm going to use the original formula. Capital A is equal to 1/2 multiplied by the base, then multiplied by the height. Substituting in, we can write A is equal to 1/2 multiplied by the base, which we know is going to be 10 inches. So I'll go ahead and write that in as 10 inches, multiplied by the height, which is 9 inches. Well, we can technically multiply in any order since it's all multiplication, and multiplication is commutative, meaning you can do it in any order. I'm going to multiply half of 10 first because I know that's just going to equal 5. So we'll have 5 inches, and we'll multiply that by the 9 inches that we still haven't touched yet. That's our height. Now multiplying 5 times 9, we can find out the area is equal to 45 square inches. The area of this triangle is equal to 45 square inches. And what that means is that we can fit 45 of these 1 inch by 1 inch squares inside of that triangle. Example 7. Let's find out the area of this triangle. Right away, we see this 12 along the bottom, and that's going to be our base. So I'll say the base is equal to 12 centimeters. Then we have to decide what the height is. So there are 2 measurements that we could potentially look at, and just keep in mind that this measurement of 25, while that might be helpful for finding the perimeter, it doesn't help us with the area at all. When we're looking for the area, we just want the perpendicular sides, which is the base and the height. The height here is going to be 18 centimeters, so we can say that the h is equal to this 18 centimeters. Let's go ahead and see if we can find out the area of this triangle. Going ahead and writing our formula, we can say capital A is equal to the 1/2 multiplied by the base and the height. And making some substitutions in here, we can say, okay, the area is going to equal 1/2 multiplied by b, which is going to be 12. We'll say that's 12 centimeters. And we still have to multiply that by the height, which is going to be 18 centimeters. Now we can multiply in any order. We could take half of 12 or half of 18. Maybe I'll take half of 18 to make that number a little bit smaller. So half of 18 is going to equal 9. And don't forget, we can really do this in any order we want to, just because we're just going to end up multiplying anyway. But half of 18 is going to equal 9. So I'll go ahead and write that's going to be 9. Half of 18 centimeters is 9 centimeters. And we're going to multiply that by the 12 centimeters that we still have for the base. Okay, so 9 times 12, I'll just write it out just in case it helps you see. So 9 times 12, 9 times 2 is going to be 18, carry the 1. 9 times 1 is 9, plus 1 is 10. So that's going to be 108. So we're going to say that the area of this triangle is going to equal 108 square centimeters. The area of this triangle is equal to 108 square centimeters. And again, what that means is that there are going to be 108 of these 1 centimeter by 1 centimeter squares inside of this triangle. Example 8. This triangle that we're given here looks like a scalene triangle just by looking at the side lengths and looking at the angle measures. It looks like we have a right triangle. So this 18 yards going along the bottom, that looks like the base. So I'm going to go ahead and just say, okay, that base is equal to 18 yards. And for our height, that looks like it's going to be this 4 1/3 yards. So I'll go ahead and write that down. And given the base and the height, we're probably going to be looking for the area here. And that's what we'll do. Let's go ahead and write our formula real quick. And substituting our values in, we're going to write at this point, remember that when we're multiplying fractions, we like to have improper and proper fractions, so let's rewrite any of our fractions or whole numbers into this form. So 1/2 can stay the same. 18 is a whole number, but as a fraction, we can write 18 over 1. I'll go ahead and write the yards as well, even though we could save it for later. And 4 1/3, 4 times 3 is 12, plus 1 is 13, so as an improper fraction, we can write that as 13 over 3 yards. Rearranging this just to make this a little bit more organized, let's say that the area is equal to, I'll write all the numbers, we have 1/2 times 18 over 1 times 13 over 3, and at the end we have yards times yards, so that's going to be yards squared. And let's see if we can simplify this multiplication problem before we actually multiply. So the 2 and this 18 can cross cancel. Their GCF or common factor is 2, so dividing them both by 2, we're going to get a 1 and a 9. And then we can go ahead and simplify this 9 and the 3. So 9 and 3 have a GCF of 3. Dividing them both by 3, we get 1 and 3 on top. Okay, so if we go ahead and now just multiply, because there's only ones left on the bottom, we can't simplify anymore. On the numerator, we have 1 times 3. Let's just circle that. We have 1 times 3 times 13. So 1 times 3 is 3, then 3 times 13. That should be 39. And on the denominator, we have 1 times 1 times 1. So 39 over 1 is just equal to 39. So we can say that the area is equal to 39 square yards, or yards squared. The area of this triangle is equal to 39 square yards. And all that means is that the triangle is made up of 39 of these little squares that are 1 by 1 yards. In example 9, let's try a slightly different type of problem. So we're given the base down here, which is going to be 26. So I'll go ahead and write b is equal to 26 centimeters. Now as for the height, we actually don't know what that is. So our h is going to stay unknown. We're going to figure out how many centimeters long that is, or how many centimeters tall it is. And lastly, we're actually given the area in this problem. So we know that the area is equal to 117 square centimeters, or centimeters squared. Given the base in the area, we're going to work to see if we can figure out the height of this triangle. Let's start by writing the formula. Using the information that we were given, let's substitute in some values. On the left side, let's leave this 117 square centimeters alone. And on the right side, let's clean up this a little bit. So 1/2 of 26, well, half times 26, or half of 26, is just equal to 13. So it's going to be 13, and then we have centimeters. And we're still going to multiply that by the h centimeters, which we don't know yet. To figure out the height, we're going to have to get it alone on one side of the equation. Because on the right side, this 13 centimeters is being multiplied by the h centimeters, to get the h centimeters alone, we're going to have to divide both sides by 13 centimeters. On the right side, 13 centimeters over 13 centimeters just equals 1, and by the identity property, we can just cancel that out. As for the left side, dividing this 117 by 13, let's see, 13 doesn't fit into 1 or 11, but it does fit into 117, I think 9 times, right? 9 times 13 does happen to be exactly 117. You can check me on that if you'd like. And that should equal 0 for the remainder because it goes in perfectly. So we find out that this 117 divided by 13 is going to equal 9 exactly. So we'll have 9. And then as for the units, well, centimeters squared divided by centimeters. Centimeters will cancel out on the one of them on top and the one on bottom. And so we're just left with 9 centimeters. This is going to equal the h centimeters that we had earlier. We now know that 117 divided by 13 is equal to 9, and we can also say that the centimeters squared over the centimeters, that the centimeters will cross out on top and bottom, but we had 2 of them being multiplied on top, so we still have 1 of those, and that's still equal to the right side, which is equal to h centimeters. Now keep in mind, we were really looking for this h the whole time, so we have 9 centimeters on the left and h centimeters on the right, so we now know that the height was equal to 9 centimeters, or h equals 9. When given that the area of this triangle was 117 square centimeters and the base was equal to 26 centimeters, we found out that the height of this triangle is equal to 9 centimeters. If you'd like to check this, you can multiply 26 times 9 and divide it by 2, and that'll equal 117. Here's one final example. Let's see what kind of information that we have. So this 8 yards here, that's going to be the base. So I'll say b is equal to 8 yards. And then we have this h over here on the left side. We don't know what that is, so we'll say the height is going to be something. We'll look for that. Be something yards. And then finally, we're given the area here is 24 square yards. So we'll say that area is equal to 24 square yards. Just don't forget the little squared for the area because it's 2-dimensional, while base and height are just 1-dimensional measurements. Okay. Now that we have our information and we know what we are given, let's go ahead and just write our formula down. Substituting in the values that we know, let's go ahead and write 24 yards squared is equal to 1/2 multiplied by the base, and the base here we know is going to be 8 yards, multiplied by the height, and that's going to be h yards. The left side looks simple enough, so I'm just going to copy that one down again, and let's just mess around with the right side. So we could take half of this 8, that seems like a pretty easy thing to do. Half of 8 is just going to equal 4, or half times 8 equals 4. That's going to be 4 yards, and that's going to be multiplied by this h yards that we're looking for. That's our unknown still. Now, just like the last example, if we have 4 times h equals 24, or 4 times something equals 24, let's go ahead and do the opposite operation, or the inverse operation. Let's divide the right side by 4 yards, and let's divide the left side by 4 yards as well. So on the right side, 4 yards divided by 4 yards are going to cancel out, equals 1. And on the left side, let's see what's going to happen over there. So 24 divided by 4, that's just going to equal 6. So we'll have 6, and then as for the yards, or the units, yards squared will cancel out with the yards, so we still have just maybe yards on the top, but the denominator is just going to be 1, so I'll just leave that alone. And on the right side, what are we left with? Well, I know there's a lot going on, but just keep in mind that we were looking for this h the whole time, so we'll just go ahead and write is equal to h yards. Everything else just canceled out to be 1, so we don't actually have to write it. At this point, it should be a little bit more clear to us that we know the value of h, or the height of this triangle, which is equal to 6. The height of this triangle should be equal to 6 yards. And this one should be easy enough to check. So if we take this 6 here and plug it in right in for h, then if we do, the area should be equal to what? Base times height divided by 2. We should be able to multiply and say, okay, the base is 8, and the height we're saying is maybe 6. So base times height divided by 2. Well, 6 times 8 is going to be 48, and then divide 48 by 2, that's just equal to 24. And that's the area that we were given to begin with, so this does check out pretty nicely. And that wraps up this video on finding the area of parallelograms and triangles. If you found this video helpful, feel free to give this video a thumbs up, and as always, keep up the great work, and I'll see you in the next one.